Hi, this is Mrs. Bustamante. We've been talking about states of matter of different substances, the solids and what their states are, and gases and liquids and even plasmas a little bit, and how those intermolecular forces help make a substance what state it is. But we can actually also change from one substance to another in what we call a phase change. And there are six of them. So here are general phases: solid, liquid, gas. And we can melt, which is going from a solid to a liquid, or we can vaporize, which is going from a liquid to a gas, or we can even go from sublimation, solid to a gas. And vice versa, we can go from a gas to a liquid, which is called condensation, or a liquid to a solid, which is called freezing, or directly from a gas to a solid, which is called deposition. And it's important to know these and to know what changes from one state to another, but also we need to know about what types of energy are either given off or gained in these phase changes. And the three that release energy or give off energy are freezing and condensation and deposition. And if we think about that, all of these are moving from particles where they're more disorganized, they're moving around a lot, to where they're more organized and have less fluidity and less energy, really, if you think about it. And in order to change from a solid to a liquid, or a liquid to a gas, or a solid to a gas, we have to add energy. And all those phase changes are going to gain energy in one way or another to give those particles more energy and to cause them to be able to move faster and quicker. Oftentimes, this is in the form of heat, and sometimes we can change these with pressure as well. So what are these states of matter changes that we just did, or these changes of state? We went through them, we went through some of them, and how they either gain or lose energy. And we can show this on phase diagrams where we show our temperature and pressure changes and what state of matter that particular substance would be in at a given pressure and a given temperature. So this phase diagram is for water because we're really familiar with water. Typically we show pressure on the y-axis and temperature on the x-axis. It can be in different units. This one shows us some different ATMs and torrs for our pressure, and temperatures in Celsius. And on this phase diagram, we can see when water, certain pressures that water is at a solid, maybe 1 atmosphere, and this isn't labeled great, but probably just a few degrees, maybe 0 even Celsius. Water would be in a solid state. We can see when it's in a liquid, and we can see when it's in a gas state. So we could be given different points on this and asked, hey, what state of matter is water in at this pressure and this temperature? And we should be able to identify that. We should also be able to show sublimation, deposition, melting, freezing, vaporization, condensation, where those happen on a graph. And then these lines represent when water can be found both at a solid and a liquid. So if something were on the line, it could be at both states of matter. And that occurs anywhere on this graph. There's 2 points we also want to know. Point B is known as our triple point. That's where all 3 phases of a substance can exist at one time. And point D represents our critical point. That's the point at which it can no longer exist as a liquid. Anywhere higher than that, a higher temperature than that, it's always going to exist at a gas no matter what. And we can look at these for all different substances, and the graphs look a little bit different. But it tells us all the same information: pressure, temperature, when it's a solid, when it's a liquid, and when it's a gas, right? And you'll notice water looks kind of weird. That's because water has some interesting behaviors due to its hydrogen bonds when you compare water to a lot of other phase diagrams, right? Another thing I like to point out here is that when we look at things, different phases of different states of matter and different substances, we think about carbon and building fossil fuels. And we know that carbon, over a long amounts of time and really high pressures and temperature, actually turns into what we use as our fossil fuels, right? So that's just something interesting to think about when you're looking at phase diagrams and thinking about phase diagrams.